Hello, this is a continuation video for the implementation of the RFSoC loopback design, which is a reference example from AMD Xilinx. In part 1 of the video, we have already generated the clock files that will be used to configure the RFSoC board. Since in the block design we do not have the RFSoC board separately, we will be using a ZCU111 interface software to configure the board. Firstly, coming to the physical connections for the board, the input has to go to the ADC and the output has to be taken from the DAC. Using this as reference, this is the setup where this is the signal generator. In the signal generator, we will be generating a 125 megahertz sinusoidal signal with the power of minus 10 dBm. On the RFSoC board, the input from the signal generator will be given to ADC224 and the output will be taken from DAC229 and given to the spectrum analyzer. Also on the RFSoC board, we have to set SW6 to on, and on, which is the JTAG boot mode. Now comes the second part, where we will configure the ZCU111 software for the clock files. For that part, firstly, we will need to open the software, wherein this dialog box appears. In the dialog box, once you connect the USB to your system and you switch on the board, the serial number will be automatically displayed. The next part is to configure the clock files. This is the interface for the software. The clocking setup for RFSoC consists of LMK04208, which serves as the reference clock for LMX2594, which clocks the ADC and the DAC. Firstly, we will set the LMK04208 frequency. For that, we will go into the clock files folder. We will copy the file name and paste it in the dialog box and click on set, which sets the frequency. Now we can set LMX2594 frequency. This example we are doing on 1.966 gigahertz. So for that, I will be using this file. I'll paste the file and click on set. And I will be doing the same for remaining elements as well. Now, once we have set these frequencies, under the read tab, I need to read SI 570 frequency. If this frequency does not come out to be 300 megahertz, you need to go to restore defaults and click on restore. Now, since I have obtained 300 megahertz, I can set the remaining frequencies as well. These must also be 156.25. The next step is under the set boot frequency to set this to 300.00 megahertz and this frequency to 156.25 megahertz as you obtained in the read tab. Once this part is done, next part is to go to the Vivado software and using the hardware manager, we will program the board and obtain the output. This is the block design. We will open the hardware manager and open the target. The target is the board that you have connected. Since I am on the local server, I have connected the board locally. I will choose the local server. Now, once my board is on target, the next part will be to program the device. At the moment, it is showing that the device is not programmed. So I will program the device. As soon as the device is programmed, we can check the output on the spectrum analyzer. Now, once the device has been programmed, we can check the ILA. which will show the outputs. And this is the output that we obtained on the spectrum analyzer. The output that we obtained was minus 32.02 dBm, wherein minus 17 was the loss from the cable and approximately minus 14 was the loss for the loopback design. This was the demonstration part of the example. Thank you.